So inshallah, today and the next class we have another two components of chapter 4 that we have to cover, which will be part of your midterm course. How many of you have watched the 4.78? Have you watched? Yes? Yeah. Because until point 7 and point 8 is on simplification, right? Okay. So that will be what we will be covering today, inshallah. Bismillahirrahmanirrahim. So basically, this part deal with basically simplification and also further simplification. Now, in terms of the type of wording that can be used in your exam, it can be something like find the equivalent force and couple moment system, etc. Right? So you have to know, okay, that one I have to simplify to a specific point, right? And sometimes the question actually says further simplify to just one force, something like that, right? So hopefully we'll try to see what type of question that can be asked in your exam with regard to this one. But by the way, anyone who didn't manage to watch the lecture? Yes? So okay, the idea is simply just I'm just to illustrate it 2D, right? Let's say we have a lot of forces and moment, etc. So we simplify into just one specific force and one moment at a specific point, right? So normally the question will ask for that. Okay. And further simplification is basically what will it be if we will just to simplify into just one force and we have to specify the location. Right? So that's basically the idea. And all of these are equivalent, meaning that the effect is the same in terms of summation of F and summation of moment should be the same as summation of F and summation of moment here, summation of F and summation of moment. All of these should be the same, right? So that's basically the idea. So if we can calculate all the summation of moment in the original case, it should be the same as the effect of this moment and this one, right? So that's basically the idea. Right. And in the lecture, I think we have covered how many examples is it in there? Is there an example in the yeah? So you can follow the okay. Let me see. One, right? This one. We have four examples, right? Alright, so we will just take a look at the midterm question and to see whether we have this kind of question. Now, I think if you have browsed through, most of the recent midterm will not have this question because many of the previous semester because a lot of holiday on the class session, meaning that many of the section cannot finish the syllabus before midterm, so it's just until couple moment, right? So you can see here, there's no question with this part, right? This one, except for this one. Okay, this one. This is okay, let's read this question. Okay, this one. Okay, this one is still resulted. This is not moment. So there's no so there's no from question from midterm, so let's take a look at the exam. If there's none, we have to find new version from the textbook. This one. Okay, this one is 4.9. There's a 4.9 components over here. So I think it seems like in the recent history of statistics class, actually you are the first section, the first semester. Okay, I don't think this. Alright, interesting. So we do not have any. So that so alright. So I have to draw the question then. So we just go to some example questions here in okay, there's a lot of shape, but basically the idea is quite simple, so we'll just try several. Okay, let's take a look at it. I'll write the question in because we'll try some of the different type of distributed loading. Have we covered distributed loading yet? No. No, that's 4.9, right? Alright, so we'll cover 4.9 first. Because, okay, there are some, otherwise I have to cover. Okay, might as well. How much time do you have? How many of your class depan? Okay, on the actual 4.9, I'll. Berapa minit lagi? Okay, I'll just give you a gist so that even if you have to go after this, at least you know what's the gist of 4.9. Now, basically, because normally the question will combine 4.679 or something. Meaning from the simplification question will also include distributed loading, right? It will not be separate question. Now, for distributed loading, let's say if you make it something like that, right? Now, okay, after this, for those who have still with me here, I'll just go through the concept. But now it's just for the calculation part, meaning that if you just memorize, it's basically area under the graph, right? You understand the concept? If we have the distribution of this force, what does it mean? Normally it will be something like, for example, 5 kilonewton per meter. It's basically a distribution, meaning for every meter, the total loading is 5 kilonewton. That's what it means. So if you have 2 meter, then 10 kilonewton is the total, right? That is the meaning of this unit. So it is distributed, right? Now, if you have, okay, this is simple one, right? When we do statics, for example, it is acting on a beam like this, right? So, but in the static, we need to replace this with one single force, because otherwise we cannot calculate the location, right? So basically, in terms of the value, that one single force should have the same value of this whole distributed loading. You understand that diagram? So for example, let's say the distance is 2 meters, right? So this single force should carry all the loading of this total distributed loading. So what will be the force? Right, so it's basically 5 kilonewton per meter times 2 meter, you get 10 kilonewton, right? So the idea is simple when you have a linear like that, right? Because it's distributed evenly. And what's the position? Logically? At the center, right? If it's evenly loaded, so the equivalent should be at the center. So that's, we will prove in the term of the concept after this, in terms of how it relates to integration, etc. But this is for the purpose for those who will need to go shortly, right? And that's another one. If we have something like this, like a triangle, meaning it distributed at one end it's 0, at the other end is the maximum value throughout the distribution. Like, let's say, let's say 3 kilonewton per meter at that point, and at this point is 0, right? It's distributed like that. Now, it will be, if you want to put it as one force there, what will be the value? If this is still, let's say this is still 2 meters. What same? Okay, can you make, okay, for this one, can you understand if I say this is basically the same as the area under the graph? Meaning the height is 5, this one is 2, then 5 times 2. So the same concept applies here. It's basically the area under the graph, where if this is 3, this is 2, what is the area? Half 3 times 2 becomes 3 kilonewton, right? If you plug in this 3 kilonewton per meter and 2 meters, right? So it will be basically like that, right? So it's basically just the area under the graph. What will be the location? This one is easy to understand, right? It should be in the middle if it's distributed evenly. This one, if it's meaning it's distributed like that, quarter. Okay, logically it's closer to the right or to the left or straight in the middle? To the right. Why? Logically, it's that side is heavier, right? In that sense, it carries much more, right? Now, basically, if you just want to memorize, we'll show the calculation after this. It will be of the ratio of 1/3 of the length to 1/3 of the length. That's the ratio. Kenapa? Tak percaya? Tak faham? Kenapa tak nombor lain? Is there any question? Which one? Yang cakap ni? Ni? Force day. Oh sorry. Yeah, okay. This is okay. Speaking of this thing, can you imagine? Pressure per meter square. Because pressure is per area, right? But it's the same concept. It means that basically for every meter, the total load is 3 kN in that case. So the idea is that but it is not distributed evenly like that. So meaning at this one is 3 kN per meter. Okay. Of course, it's over meter because it's distribution. Alright. Any question? Now, okay, this one is what normally we just memorize. After this, for the full video on the concept and even right after this, we will cover how to prove this one to be correct using integration. But because the original equation is integration, right? Meaning when you have distribution, you have integration. But when it's linear, then that integration you can just simply it's a linear, right? But in terms of answering in the exam for this chapter, it will always give you something like this, meaning that it is only combination of these two shapes for this chapter, for chapter 4. When we go to chapter 8, 9, 10, then you will have it is something like whatever you have to integrate, right? But for this chapter, it's just basically these two. So that's why I'm showing these two, and normally we just apply. This should be at the center, etc. Right? Now, can you imagine what to do if you have something like that, based on this basic? Basically, we can distribute. No, we can split into the basic shape that we know, right? So, basically, so we have one triangle here, one rectangle here. Okay, this one if you just want to. Okay, trapezium. Now I know trapezium you can determine the area, but the position you cannot. You don't know where it is. Understand? For rectangle, you know it's at the center. For triangle, you know the ratio of 1/3 to 1/3. But for trapezium, you do not know. So that's why we do not cut into a trapezium. So if this is a rectangular and this is triangle, then this is okay. So the idea is, for this particular triangle, you have one force here, right? Where, okay, what's the height here? This is the total 8, right? But if you consider this triangle, this is 3. What is this base here? 1.5. So the value will be half, 3, 1.5. And the location is basically 0.5 distance here, 1 distance here. Can you imagine? That's what I do. For this one, it will be somewhat here. The value will be, this is 0.75. This height is 5. So it will be half, half 5, 0.75. That's the value. This one will be 0.25. This one will be 0.5. And then this one, it should be at the middle, right? What's this line here? 2.25. So the value will be, what is hiding? 5, is it? So 5 times 2.25, and then the position is 1.125. 1.125. So basically, you get something like this. So you have 1 force here from here, 3, 1.5, and then you have force here, which is 5, 2.25, and then you have force here, which is half 5, 0.75. And then from here you go to the simplification and further simplification, which is about 4.7 and 4.8. Because the question actually asks, okay, what's the question? Replace the loading, okay, right. Replace the loading by an equivalent resultant force and couple moment. Resultant force and couple moment at point O. At O. Right? So the question that we have covered about simplification, very rarely it starts like this. Normally combine with this one to start somewhere here. So you have to combine the understanding of distributed loading, that is 4.9, and then from here you bring everything to point O. Right. So we'll continue that now, but just in case. So because it's time for some of you, so when you need to leave, you can leave. But do watch the recording. Right. Alright, so what to do next for the simplification? Kita tengok recording kan? What to do next? Because we want to simplify everything into point O. Meaning that we bring everything here, right? Good? So this will be FR, right? And then you will have also MR. So that's basically when you get the question like this, replace the loading by equivalent resultant force and couple moment at O, you know, okay, this is the type of answer that I want at the end. How to get this value? So how to get MR? In this case, it should be easy, right? Because everything is downward. So basically, MR is just summation of all of this. Understand? Process. Right. So basically, summation of all the forces. What about MR? Summation of moment. What? About point O, right? Because that's the equivalent, right? Meaning that the moment here is basically should have the same moment effect that each of these produce about point O. Right? The rotation tendency, right? So MR here should be this force times this distance, and this force times this distance, etc. Right? Now, so that's how we do step by step. Right? Now, for question like this, I do suggest, even though it's not compulsory, you show, meaning when you calculate this one, the distance you straightway put this is distance, and this distance. It's not compulsory because if you put like something like this, when you want to calculate, sometimes you make a mistake of taking this or taking this, you forgot to add. So might as well from the beginning you just have a habit of every distance is straightway from O, so when you want to calculate, you just include that distance. And to check later on is also easier in the exam. Otherwise, this one when you check is also, meaning it's too messy, right? You want to check the distance, so you will get panic and etc. Right? So in the exam, it's best to have a habit that help you in terms of avoiding mistakes. Please try and see what you get. Anyone who do not follow anything, please ask. So the value are there. Try on own from here to here to here. Or you want to try a different image? Any question? Or you still do from here to here? Do you need more explanation? Because we haven't covered the lecture yet on that one, right? I'm just giving you the equation that you can use straight away just now. Do you need extra that one first or no? Oh, tak bagi perhatian dah. Kat mana soalan? Yap. Macam mana nak ikut? Determine ikut apa? Tak apalah, bila lebat nanti tengok apa statement yang itu. But logically you should be able to tell, right? This one will rotate clockwise or counterclockwise? Because everything was there, logically it's clockwise. So that's why I put clockwise, so I don't have negative. But if you make negative to clockwise, then everything will be negative, and then you can say it's clockwise lah. So it's the same. Okay. Okay, the question like this. The question will not ask. Meaning the question only asks this one, right here. However, because to get here, you have to calculate moment is force and distance, right? So if you do not know where it is, you cannot calculate the moment. Or if you make a mistake of the position, your answer here will be wrong. Because when you calculate this moment, is actually summation of force times distance. Meaning force times distance. So that distance is where this is important. If you do not know this one, then you will be stuck. Meaning, that's where sometimes the question, if you do not know 4.9, even though you know 4.8, you still will get it wrong because the starting point is 4.9. Meaning that's how the question can be. Right. So, anyone need further understanding on this part? Okay ke? Jawab soalan. Lepas tu makin cuak lah. Yang boleh lepas ni. Dia tak boleh teka, dia faham. Boleh teka, dia lepas tu. Moment resultant tu tak ada step-by-step. So step ialah daripada macam ini dijadikan single port. So step bila dah single port then you change satu juga dan single port dan single port dan daripada from here to here setiap kotak ni ada force dia dengan distance dia. Maksudnya force dengan jarak. Here you want two things. One FR resultant force, satu moment resultant. So resultant force ni tambahlah force tu. Sebab ni senang lah. Kalau you ada XY lah. Resultant moment ni ialah jumlah keseluruhan hasil moment oleh step satu tu. So yang moment ni jarak distance dia lah. Ni jarak distance dia campur semua dapatlah moment tu. Maknanya basically okay. Ada yang sampai habis tak? Belum? So jawab ke? Tak. If the question say kalau the question is need for those who have batch FR and MR, right? Then further simplify into single resultant force and specify its location. Do you understand? Do you understand the question? Tak. You tengok lecture tu tengok. Oh, belah tak. I just want okay. Because what we did is this one is from that one into just this and this, right? So the simplification is, and what is the distance? And then from here to here. Lagi tahu. Ada kan dalam lecture tu ni? Ke tak ada? Ada. So do you know what to do? Yeah, because the idea is summation of moment here should be the summation of moment here, right? Summation of moment here is MR tadi lah. Summation of moment here is FR times T here, right? FR is already known, MR is already known, so you can calculate for T. Then you get the distance lah. It's basically a reverse calculation lah. Because the resultant force should be the same. FR is FR still, right? The difference is where is the position. Okay? Any question?
So the force is going to be the summation of all these. For example,
Yeah.
if we take this.
Of course, it will be. This is the simplest type of question because everything is covered, right? If you have an angle, then you have to have x and y, and then you have to calculate the resultant. FR is the resultant, and then you have to have the theta. Right, so that's. If you have 3D, then you might need then. In 3D, sometimes you need to cover using R cross F, right? This is summation of R cross F, something like that. But the idea is the same. Okay, you want to try this one? This one actually come out in the, when was it? One of the exam. Okay, there's one semester. What is it? Oh no, this short sem I think. Because I didn't teach in the short sem. I think Dr. Anand did. And I think she did give this question, if I'm not mistaken. But the idea is simple, right? What do you do? You just ignore all the books. You just focus on the. This one is one triangle, right? And this one is another triangle. Not triangle. Rectangular. Okay, that's a test if you ask. Anyway, this one is simple, right? I'll just give you this one because this one. Okay, let's use this one because you have to divide the sheet and see what you get. The same question. Basically, replace the note by equivalent, but at A. Right? By equivalent force and couple moment at A, and then simplification. Just to see if you have any problem. This one is when you have covered chapter 5 and 6. Maklumat spontan dengan maksudnya kan? Kita tak tahu lagi. So kita dah selesai yang kat atas. You minus rectangle atau apa? Okay. Because we haven't covered properly chapter 4.9. Okay. For some of you, okay, because I'll just put this one first, right? So we have. Basically, you define put this to shape, right? Okay. If for anyone who, when I draw it here, it's complicated, right? So if we take out the two shapes, it will be something like this, right? So for this shape is 2 kilometer per meter and 6 meter, right? This one will be 3 kilometer per meter and 6, right? Now, in terms of the value, I assume everyone have no problem, right? This becomes 6 and 2 is 12 kilometers. This one becomes 9 kilometers, is it? 1 over half times 6 times 3. Right? What about the location? Any problem? This one it should be at the middle, right? So meaning this distance is 3 meter, right? This one? This distance will be 4 meter, right? Why? It's 1/3 and 2/3 of the ratio. So if we redraw back here in the new diagram, this 12 kilometer will be very at the middle, right? 12 kilometer with the distance of 3 meter, right? And then this 9 kilometer will be there with a total distance of 4. This one is 4 meter, right? Something like that. So then if we calculate what is the equivalent resultant moment and force and moment, so Fr here is basically the 12 plus 9, right? It's basically just the result, the force here should be the summation of everything here. And the moment here, Mr, will be what? Basically this times this plus this times this, right? Basically it's 12 times 3 plus 9 times 4. Right? That's how the calculation works. Okay, if you further simplify, what will happen is basically you shift Fr somewhere there, right? What will be the distance? Anyone have calculated? This distance. What do you get? Same as anyone? This is the second part. This one, basically F times distance here should equal to Mr, right? Because the summation of moment here should be the same as summation of moment there. That's the concept. Now, for some for this step from here to here, do you understand? Kenapa distance macam ni, kenapa distance macam ni? You have to look individually macam ni lah. Yang sini semua faham? Kenapa 4? Apa yang faham? Itu nak kata faham, boleh. So hafal sebenarnya. Because there's a reason why it's 1/3 and 2/3. But we haven't covered that one right now. Do you need? Are you interested to know why is it 1/3, 2/3? Or no? Because in terms of statics exam for chapter 4, you tak faham pun tak apa, you boleh jawab score. But for mechanical student, that understanding will help later lah when the shape is not like this. Right. But before that, because this one is easy, right? Because you will have shape like, okay, this one is still easy, right? But it's just one. Right now, all our questions that we have covered so far is every force is in the same direction. Now you have on the top here you have downwards, bottom here you have upwards, right? This one Combination of how many shape? So depend how you. But the rectangular can be just one long triangle, rectangle there, right? What about this one? Okay. I think when we did this one, I think there's a lot of questions we have done put in the exam, but I couldn't track. I think it's like 9 years back. I'm not sure whether it's fortunately or unfortunately, because if you take question paper over the 10 years, it actually becomes easier and easier and easier and easier. Tapi markah apa juga? Not sure why. From the lecture we are puzzled because students score SPM macam makin tinggi, tapi kenapa? Macam tak boleh jawab soalan. So, but anyway, do you know what to do here? Can you imagine?
Yes.
It's still the same concept. This one will have like a rectangular, right? And then the triangle there, right? The idea is simple, but if you try, then you have to give this all the angle, right? Now, okay, what if you have something like this? What do you know what this is? Moment. So, how it will affect? So, if you have something like this, for example, if our question here, if you have something like this, right? How will it affect it? Let's say it is like 10 kilonewton meter. Let's say, in our previous question, right, we have this. How will it affect here? Faham soalan? If, okay, because our question, we don't have something like this before, right? So if we have that kind of moment from the original question itself, there's a moment here. How will it be, what will happen here? You have that moment here, right? 10 kilonewton meter. You don't need to calculate that. Okay. If you have this question, because this question combines the shape, distribution loading, and just single loading here and moment here. Right? So meaning that this triangle will have one force here. This triangle will have one force here, right? So in the end you have one force from this triangle, one force from this angle, and one moment like this. Okay, because I think with the force there you know what to do. But with this moment, like for example we have this moment here, how will it affect here? So this moment resultant have to add 10 there. Add or minus depend on the rotation. In this case, because clockwise, everything clockwise, and this is also clockwise, you have to add. And the value will be different. Because it's also a moment. Because we calculate summation of moment. From force and from moment, originally moment, couple moment. Faham ke? This is still 2D. Okay, this is where it requires integration. But for our syllabus, we skip this one and we'll keep it in chapter 9 or 10 where we will use the integration. Right now we just use because this chapter is not about integration, this chapter is about moment and stuff, right? So we just keep it. But later on we have to understand still. Now, okay, in terms of we have time? Now, this is what I do. I'll just open one. Which one you want to try? The one there? This one? Okay, for those who want to try, please try this one. Find at A. Hanya replace the loading equivalent blah 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 at point A lah. Okay, right? You can try. For those who want to listen or to the explanation of kenapa jadi two-third, one-third ni, I just go here, right? So it's up to you. Bisa beli barang kan? Bagi ada yang nak kenal ke? Tak jumpa. Okay. Basically it's like this. It's in terms of integration. The idea of the integration is actually from here to the further simplification. Okay. If you have, let's say, 1 Newton here, 1 Newton here, 1 Newton here, right? And then this is point O, and then 1 meter here, 1 meter here, 1 meter here, right? You get the idea. So if you put it like this, FR and MR, you know what happened, right? FR is just 1 plus 1 plus 1, the total. This one is just 1 times 1, okay? 1 times 1 plus 1 times 2 plus 1 times 3, right? So between 1, apa ni? 6. This one juga apa nombor ni? Okay, 3 lah. Now, and then you want to have it just one single point here, right? So basically the value is still that one, but this distance is this moment 3 times d should equal to 6. So d equal to 2, right? For the particular case. So meaning that this equal to this one. Now the idea is this one is if you realize d equal to this 6 is moment, right? Over force. Right? Resultant moment equal to force. Now in terms of integration, that T is integration of moment apa? F dx over integration of df ke? Apa benda konsep ni tadi? In terms of weight, right? If we have distribution of weight, and ini apa? Yeah, what's the equation? X dA or X, okay, sorry, dx, because the area is force. Okay, so the area is force. Okay, so let's say D, yeah, or X is integration of X dA over integration of dA, right? dA, when you integrate dA, what you get? A, right? Area under the graph is basically force, right? When you have force like this, and X is basically the distance of any particular force, right? So force times distance is moment. This area is force. So it's basically just moment divided by force in terms of integration. Right. So if I have a linear like this, right? Let's just give a value, right? 5, like that. And then this is 2, right? D. How do I integrate? What will be the limit? If I want to integrate across this one, 0 to 2, right? From 0 until x equal to 2, right? And then x and dA. What is dA? Okay, no. 10 is A, right? Okay, nak di A ke di X ni? Okay, we have a, okay, have you done integration before? In terms of dA, how do you get dA? Basically, you have to split into one tiny section, right? You still remember? You split this one, where this one is dx. In this case, this is 5. If this is y, then y dx. So, meaning that dA is, in this case, 5 dx. Because dA is the area of one differential element. Okay. If you remember, early in the semester I put 2 videos, right? One is trigonometry, one is integration. So in the integration, I talk about this thing. If you cannot recall, you just watch like what is the element as well. You have learned it before, right? Tapi biasanya kita tak guna untuk hidup ni. Normally we do not know where to apply this one, right? We go to the supermarket, there's nothing like that. But for mechanical, for this one, you need to know that one back, right? So in that case, you replace dA with 5 dx, right? And then 0 to 5 dx. Do you know how to integrate this? This is basically 5x. Integrate 5x equal to 5x squared, right? And then you have a limit of 0 to 2. And then this one, what is this? This is 5. Come, 5x from 0 to 2. What do you get here? 5 times inside of 2. Oh, sorry, over 2. This one is right? So I understand. So this one becomes 4 over 2, right? And then this becomes 5 times 2. What do you get? 1. What does it mean? Meaning that for from 2 here, then the distance is 1, right? Okay, if we put L, right? I'll put L senang. Okay, if we put in terms of, because I like to use value, because when we put something else, it's sometimes harder for some people to comprehend. If we just put this is equal distribution like this, right? Let's say this is W, because it's weight going down, and this is L, right? So if we do the integration from 0 to L, right? From 0 to L. And then x, and then the A is what? If you put this one, it will be, this is the x, this will be W. So the A is W dx. So you get W dx over integration 0 to L, W dx. Integrate this. Wx square over 2 from 0 to L, Wx 0 to L. So basically you get W L square over 2, right, over W L. So what do you get? You get L over 2, right? So meaning that for any distributed value like that, the force will be halfway, basically at the middle. Confirm that what logically we know already. This one, right? What if it is a triangle? What if it is a triangle? Where this is 0, this is W, and then this is L. So if you do D equal to integration of 0 to L x betul ni dA is what? If we take one step here, one step, this is the x. What is this height? W, okay. Okay. So it will W dx, is it? Yeah. If this W equal to what that? No, y equal to mx plus c, right? If this is 0, mx, right? So if you replace y is w, then mx, is it? Okay. So integration of u to L. I think I forgot something. Because if you use number, then it will become what? Obvious. Okay, if we put number, I don't know. What did I miss? Put the number. Okay. Because we have to have this rule, right? Okay, w dx. Okay, this is correct. But w is a function of x, right? So, okay, this is not going to y. Do you understand w more or y? Okay, if I use this curve, because this is a curve, right? Y equal to mx plus c. But if you c is the if we consider 0, 0, right? We make it easy. Right, so it will be, here will be, this will be y, correct? Y here. But we have to insert y equal to what in terms of the function of x, right? We cannot integrate y here, we have to convert it to x, right? So in case, okay, then we'll put m, right? So 0L x and x dx over integration of L and x dx. So what will happen when we integrate? Because this is mx squared, right? So you get mx cubed over 3 0L and then mx squared over 2 0L, right? So what do you get? Basically ml cubed over 3 divided by ml squared over 2, right? What do you get? 2 over 3, right? 2 over 3L. So the force here is 2 over 3L. And of course then this will be 1 over 3L. That's where the ratio comes in. How to prove if we have the opposite triangle? Because if you have like this, right? It should be 1/3, right? But what will happen? What will be the equation here? Negative mx. But you have a plus something here, right? So it's easier if you have a number. So if what number do we if this is 0, this is L, the slope is 1, for example, right? So what will it be here? It will be L, right? So minus 1x plus L. Boleh ke? Faham ke tak? Katalah tanda ini, right? The slope is minus 1, the intersection will be L. So what will happen here? Macam disahkan ni relation. Because y equal to what? So you have minus x. Okay, tahu? Tengah sebelum mencapai di ni kan. This one is very right? So integration of 0 to L x times minus x plus L dx over integration of 0 L minus x plus L dx. So this one is basically integration of 0 to L minus x squared plus xl dx over integration of 0 to L minus x plus L dx. What do you get? Minus it, that's cube over 3, and then plus x squared semangat, so tengok ni makin malas. So minus L cube over 3 plus L cube over 2, right? Ini bawah ni minus L square over 2 plus L square, right? What, okay, 1 over 2 tolak 1 3 berapa? Minus 2 over 6 plus 3 over 6 is 1 over 6, right? 1 over 6 L cube over setengah, eh? 1 over 2 L square. Then you get 2 over 6 L, right? Or 1 over 3 L. So that's why it is 1/3 here and 2/3 there. So it will be just the ratio. That's why this one is the derivation. In application we just memorize, right? But if you understand how this becomes that number, if whatever function you have, you can just derive back again, right? And that is useful for later years lah, third year, fourth year punya subject. Alright, so that's basically the derivation. Ada yang sono ni lah saya ikut E ya, tak ada. Do you enjoy this kind of? Okay, tak sono ke? Bila dapat tu lah. Bila tak dapat tu apa dah. Alright, so is it time already? Dalam buku ke? Tu 1/6. 4, 1/6. Ada. Ni kalau 14 edition. Oh, I forgot to return your. Balik dah. So this is quiz nombor apa dah? This is quiz 4 I think, right? So for the sisters, for the brother. Okay, so in the next class, ni kita kira dah habis ke ni 49? Because 4.9, okay, 4.8, the distributed loading, the simplification, I think in the lecture video I also cover 3D, some 3D, right? Ada R cross F kan? But in chapter 4.9, the distribution is only on 2D, right? Okay, do you want any quiz next class? Okay, next week. Next week datang. Okay, so straightforward question. Now, according to the timeline, our chapter 4 should end this week. Of course, we have another class. Next week, we should already go to chapter 5. However, because on the Monday class, normally your mindset is on the midterm, right? So if we want to be read at chapter 5, you have to understand the implication lah, because the time given will be shorter than it originally is. So, and meaning that I'll still post as if there's 2 class, but you have to watch right after the midterm or something to cover that 2 classes lah. Otherwise, if it drags too much, then it will affect us much later, right? So, is it agreeable that way? Alright. So with that, on the next class, because there's no exam question for this one anymore. So if you have any question, you pinpoint from the textbook, especially those that looks difficult or whatever, you can pinpoint so that we can discuss that one. But if you just come and no one asks question, then I'll just randomly find something lah. But that might not help you, especially if you have specific thing that you do not know yet, right? So if you can pinpoint, it's for your own good lah. Then the rest just follow who do not have anything. Alright, so we'll end the session here. Subhanallahumma bihamdika. Right. Assalamualaikum warahmatullahi wabarakatuh. So I just remind, kalau dia tak ni lagi, the midterm actually cover until the end of chapter 4. And hence, if you refer to any of the previous exam as before I mentioned, I show There's no question like this, but for sure it will come. I'm not saying it exactly like this because it can be 2D, it can be 3D. Right? So 3D macam yang dalam itulah. Kalau kita nak cover 3D in the next class pun boleh. If 2D, normally it will be something like this lah. It combine with 4.9. So be prepared with that one insyaAllah. Yep. Oh, kelas pun tak nak dah. Okay, that's why I asked, because I just follow what the student want. Because if I teach chapter 5 and all of you still then there's no point. But the implication is as I mentioned just now. So meaning that we have another 2 class before the midterm. Next class we will still focus on chapter 4. I think next Monday, overall of whatever chapter that is relevant for midterm lah, if you have question. And it's best if you have question. Otherwise I do not know where to randomly pick, right?